Right, this is a really quick lecture because the exam is tomorrow and it's on the density, and that's why I'm not using the projector because it's just a very quick one. Right, now the method, all you have to do to find the density, which is done in terms of rho, is use this here, and this is saying that rho times the Jacobian is equal to the rho at the origin at the point using the points big X, and the Jacobian is here if you don't remember that. So you've got dx1 over d big X1 all the way up to dx1 over d big Xn, and down here we're just changing the m's going across, so the little x is each row and the big X is each column. Right, so now we're going to use the example which we used in the streamline and trajectory solving video, and for that we got the trajectory here, which is x1, x2, x3 of big X1 e to the t4 over 4, big X2 e to the t3 over 3, big X3 e to the t5 over 5. Now what we want to find is we want to find rho. Remember, this is rho in terms of x and t. I think if it was in terms of x, t and s, then you could use the streamline one, but it usually actually asks you for rho in terms of x and t, so that's why we're using the trajectory. And we're given that at the origin, so t is 0, that rho is x squared. Right, now first off we want to find the Jacobian, and it's nice and easy because there's only x1, x2, x3 involved in each of these going down. So they just get rid of, and they get put on the diagonal down here, and we want to find the determinant, remember, so we multiply them, which gives us here, and as we multiply exponentials, that we can just add them at the top, right there. Right, now what we want to do is we want to put the Jacobian into our formula, so rho times the Jacobian is equal to x squared, and this x squared, remember, is in terms of big X, so we're going to multiply that. So to find our big X, we're just going to simply, here's our big X1, move this thing under there, so we get X1 over e to the t4 over 4 is equal to big X1. You might have to do some solving, so you might have to work out this X1, then substitute it into here, and work out X2, then substitute each of those into the last one and work out X3. You might have to do some of that, but we don't have to do in this example. So we've got our big X1, big X2, big X3 squared, and they're all multiplied together. So now we have rho j is equal to, I've just simplified this a bit further, got x1, x2, x3, they're all squared on the top, and then we're dividing it by each of these which I've squared, so the 4 cancels with the 2, because when you square your exponentials, you're just multiplying it all by 2, the power. So we've got the 2, 3 to go at top of here, and a 2 to go there as well, so we've got 2, 5, t to the 5. Now, what we want to do is we want to get our row on its own, so we're going to move this big J, Jacobian, underneath here, it's like here, which means they multiply, which means they add, so we're going to add them together, and we get the solution of rho is equal to x1, x2, x3 all squared, divided by e to the power of 3t4 over 4 plus t cubed plus 3t to the 5 over 5. Good luck tomorrow.